test using dry nitrogen, evacuation, gas charging and oil charging. Hello students, welcome to this module of the R and ACT mobile air conditioning. In this session, we will talk about how to perform a leak test using dry nitrogen, evacuation, gas charging and oil charging. Objectives. Once you finish this exercise, you should be able to identify and detect leaks in the AC system, safely recover refrigerant from the system, find and fix any leaks in the system, charge the AC system with the right refrigerant, perform a complete checking to ensure optimal operation.
Tools, instruments, double end spanner set, manifold gauge set, vacuum pump, recovery machine, electronic tester, two-stage nitrogen pressure regulator, adapter, refrigerant cylinder R134A, recovery cylinder capacity 5 kg, digital probe thermometer, anemometer. Materials: refrigerant R134A, refrigerant oil, new thermostatic expansion valve, dry nitrogen filled cylinder, PAG oil.
Task 1. Check the leakages in the AC system. Use safety gloves, goggles and lab coat or protective clothing to avoid exposure to refrigerants. Ensure the vehicle engine is off before starting any inspection. Familiarize yourself with car AC components: expansion valve, evaporator, low pressure vapor tube, pressure sensor, high pressure vapor tube, compressor, high pressure liquid tube, condenser, hoses. Use a manifold gauge to verify the refrigerant pressure and determine whether it is low. Inspect all AC system components such as hoses, connections, condenser, evaporator for visible signs of oil or refrigerant leak. Use an electronic refrigerant leak detector to check for leaks along the hoses, valves and connections. Start the AC system and listen for any hissing sound that may indicate refrigerant leak. Inspect the condenser for any physical damage, blockages or debris that could cause leak. Check the evaporator for leaks, particularly inside the cabin around the drain pan area. Look for worn or cracked O-rings and seals at hose connections, compressor and evaporator. Ensure the hoses and fittings are not cracked or loose and are properly tightened. Inspect for frost or ice accumulation on the AC lines indicating low refrigerant level or leak. Use dry nitrogen to pressurize the system and check for leaks when the refrigerant is removed. Inspect the expansion valve for leaks or malfunction as it regulates refrigerant flow. Make ready for vacuum test on the system to check for leaks by monitoring how long it holds vacuum. Refrigerant leaks often carry oil with them, so look for oily residue near fittings, hoses or components. Document any leaks found, the location and the necessary repair to ensure proper sealing and functionality of the system.
Now, let's examine Task 5. Charge the system with refrigerant. Use appropriate safety equipment such as gloves and goggles during the refrigerant charging process to protect against any accidental spills or exposure. Always study the manufacturer's specifications for the exact refrigerant charge to avoid overcharging or undercharging the system. Ensure that the system is fully evacuated before starting the charging process to avoid introducing moisture into the system. Ensure that all machine valves are securely closed. Place the refrigerant 134A can in a suitable position and open the can valve carefully. Monitor the refrigerant 134A can as it is being transferred to ensure the correct amount is charged. Open both the inlet and high side valve knobs on the evacuating charging unit. Allow the refrigerant to flow into the high side until the vacuum brake is reached. Then close the high side valve and disconnect the hose from the discharge port. Check the pressure gauges regularly during the charging process to verify that the system is receiving the appropriate amount of refrigerant. If the system is equipped with a sight glass, check it to confirm that the refrigerant level is correct. Open the suction port valve knob and let the remaining refrigerant flow into the system. After charging, test the system's functionality to ensure it is cooling properly and that there are no leaks. Record the amount of refrigerant added to the system and any other relevant data for future maintenance or troubleshooting purposes. Now, let's see the safety protocols to be followed during leak testing using dry nitrogen, evacuation, gas charging, oil charging. When servicing a car's air conditioning system, it's essential to wear the appropriate protective gear to safeguard yourself from harmful chemicals, refrigerants, and potential hazards. The required protective equipments are gloves. Type: chemical resistant gloves, latex, nitrile, or rubber. Purpose: to protect your hands from coming into contact with refrigerants, oils, and other chemicals that can irritate the skin or cause burns. Refrigerants such as R134A or R1234YF can be particularly harmful on direct contact. Safety goggles or face shield. Type: ANSI rated safety goggles or a full face shield. Purpose: to shield your eyes from refrigerants, debris, or accidental splashes of chemicals or oils. Exposure to refrigerants can cause eye irritation or injury. So, proper eye protection is critical. Long sleeve shirt and long pants. Type: durable, long sleeve shirt and long pants. Preferably made of cotton or a chemical resistant material. Purpose: to protect your skin from accidental contact with refrigerants, oils, or sharp components. Protective clothing also helps prevent burns or irritation caused by refrigerant leaks or spills. Closed toe safety boots. Type steel toe or reinforced safety boots. Purpose: to safeguard your feet from falling tools, heavy components, or sharp objects in the workspace. These boots also reduce the risk of injury when working under or around the vehicle. Respiratory protection. Type: a respirator or mask rated for chemical exposure. Purpose: while not typically required for most AC service tasks, a respirator may be necessary if you are working in a confined or poorly ventilated space where refrigerant gases or chemical fumes are concentrated.
Recap. In this method, we saw how to perform leak testing using dry nitrogen, evacuation, gas charging and oil charging. In this topic, we have learned how to locate and identify potential leaks within the AC system, how to safely and properly recover the refrigerant from the system, how to identify and repair any leaks found within the system, how to accurately recharge the AC system using the right refrigerant and right quantity, how to do a thorough performance test to ensure the system is operating efficiently. I trust you have understood how to leak test using dry nitrogen, evacuation, gas charging and oil charging. Thank you, students. Let's meet again soon. Goodbye.